Okay, today we're going to take a look at finding limits analytically. So let's go ahead and look at our learning goal. Students will be able to solve limits analytically. Now, I have to say that in my experience, this is my favorite topic, at least for my students. I like the graphical method, but I think they love the algebra component to this. So let's go ahead and start. Remember that to be analytic approach, we're just simply using Algebra 1 or calculus. In terms of how many ways can we solve analytically, there are three basic ways. The first one is called direct substitution. Very simple. We just simply plug in what x approaches into the function, and then you solve, meaning using a little bit of arithmetic. The next one is factoring. So that's where if we try to use direct substitution, we either get 0 or 0, or we get a value in the denominator that's 0. So we would factor the top and then try to simplify. And then the last method that we'll look at is called the conjugate method. And we'll talk about what a conjugate is right now. So on the left-hand side, you see it says conjugate method in this box, and it says the expression is radical x minus 4. Simply put, if you don't remember from Algebra 2, this is the conjugate, radical x plus 4. So the only thing that I changed is the sign in between this binomial, and so that would be the conjugate. If you're still kind of confused, let's take this one for example. The conjugate of radical x plus 1 minus 1 would be radical x plus 1 plus 1. So this would be the conjugate of the denominator here. Okay, so let's go ahead and look at example 1. Okay, solve analytically. Evaluate each basic limit. Now these are general limits. Remember that you don't have a little negative, so it's not x approaches 4 from the left. You don't have a little positive, so this is just the general limit. And let me grab Mr. Blue here. If I'm going to use direct substitution, which I always want to try first, you basically just plug in the 4. And because you plugged in the 4, you get 4. So all I did simply, and I'll go on the side here, is I said, okay, x is the function. I'm just going to put a 4 right in for x, and then I evaluate it. Well, not much needed because it's not squared, so 4 is the answer. Okay, so let's see what this one looks like. Basically, I'm going to put a 4 in for x. 4 squared makes 16. Done. Notice that as soon as I plug in my 4 in for x, I drop the limit. So once you evaluate the limit, you drop it. Okay, I hope that was easy. Remember, you always want to try direct substitution first. Okay, so let's go ahead and let's plug in a 0. We have limit as x approaches 0 of x squared minus 1 over 2x plus 3. If I plug in a 0, I get 0 squared minus 1 over 2 times 0 plus 3. Remember, as soon as I plug in that limit, that x value, you drop the limit. So it looks like I get negative 1/3 is my answer. Now you know why all the students love this. It's fairly easy. Okay, so the next one. Okay, limit as x approaches 3 of the cube root of 2x squared minus 10. I'm first going to try to use direct substitution. I plug in a 3. I get the cube root of 2 times 3 squared minus 10. That will generate for me, let me scoot down a little baby bit, cube root of 3, and it's going to be 9 times 2, which is 18, minus 10. And if I clean this up a little baby bit more, you get cube root of 8, which is equal to 2. Now if you're like, what are you finding? Basically all I'm finding is the intended height of the function. So I'm looking for what the height would be at x equals 3. Now if you're like, I still don't get it, okay, let me go up to example A. If I draw, of course I picked the easiest one to sketch, if I draw f of x equals x, that's just a line that looks like this. And if I'm approaching 4, my height in this case would be 4. So it works out. So you don't need to sketch it each time. Using direct substitution, we just plug in. It does the work for us, basically, of looking at the graph. Okay, so example 3, evaluate each basic limit. Alright, so let me go ahead and let me try to use direct substitution first. If it doesn't work, then I might need a factor. So let's plug in a 2, and I'm going to plug in a 2 into x squared minus 6x plus 8 over x minus 2. When I do that, I get 2 squared minus 6 times 2 plus 8 all over 2 minus 2. Now I'm not going to even simplify the top. The denominator kind of scares me because in the denominator I get 0. And we know if we get a number over 0, it's undefined, and we can't do that. So we need to trick this function. We need to basically try to factor the top. And kind of a hint to me was that it looks factorable on the top. So let me grab another color here. So this will be called the factoring method. Limit as x approaches 2, and you don't drop the limit until you plug in. So I'm going to factor the top, and remember that x times x will generate my x squared here, and I need two numbers that will multiply to become 8 and add up to be 6. Now because it's negative plus, I know that it's going to be negative negative, and I have a good feeling that 2 times 4 will generate 8, and a very good feeling that negative 4 plus negative 2 will generate a negative 6, and it does, all over x minus 2. Now notice that cancels out. You're left with limit as x approaches 2 of x minus 4, and now I simply just plug in. And so when you plug in, you get 2 minus 4, which makes negative 2. So that's the intended height of my function. A little bit more work, but not too bad. Okay, I'm going to assume that this is conjugate, but let me see. First thing that I want to do is I want to plug in a 0. And I always want to use direct substitution first because it'll save me some time. 0 over radical 0 plus 1 minus 1. This looks like I get 0 over 0, which is undeterminate. We'll talk about that terminology a little bit later. So I need to use the conjugate method. So limit, and I'm not going to drop the limit, even though I'm tempted to take shortcuts. As x approaches 0, of x over radical x plus 1 minus 1. Okay, so I'm going to multiply by the conjugate. So the conjugate of this denominator is x plus 1 plus 1. And I'm going to multiply that times the top and the bottom. Now, when you do this, on the top, and I'm not going to simplify all the way, you get limit as x approaches 0 of x times the quantity radical x plus 1 all over. Okay, if I FOIL this or distribute this, notice that you have a difference of squares. So basically the middle terms cancel out, and if I multiply radical x plus 1 times radical x plus 1, I just get the inside of the radical, and then it would be minus 1. Okay, so I'm in good shape here. If you're like, I still don't get it, well, basically all we used was this, a plus b times the quantity a minus b. I know you hate it when us math teachers throw in the variables there. And when you went to distribute, you get a squared minus ab plus ab minus b squared. And so the middle terms cancel out. Same thing that I just did there. Now, in terms of other things canceling out in our problem, the 1's will cancel out, and so will the x's. So now I'm just left with limit as x approaches 0 of radical x plus 1. No denominator, so I don't have to worry about the 0 there. If I plug in a 0, you get radical 0 plus 1 plus 1. Notice I'm allowed to drop my limit now. which is equal to radical 1 plus 1, which is just going to be 2. So the intended the height of the function is 2. Okay, so let's go back up to our learning goal. Students will be able to solve limits analytically. I do think you have a pretty good feel for it. Remember, there's 3 different ways. I'll see you on the next video.